Welcome back, welcome back, welcome back. I'm Lisa Blackburn. This is my YouTube channel for everything I want to talk about, science and math. I've tried to hold up my things. I'll remember this is the first one. Shh. Oh, guys, settle down. So what we're going to be doing is the notes for physical science about bonds and periodicity. A nice little fancy word talking about the periodic table. So our notes start off talking about more about the periodic table, and we have this lovely drawing of a Muppet. What did the book I read to you have to do with the periodic table? Does anybody know why I read this book to you? Family. And where on the periodic table are the families? Are they the lines going up and down or side to side? Which one do you remember? Somebody know it? Up and down. And how you can remember this, a period of time would be like a week. It's not every Monday. So the families or columns go up and down. Now, the next thing we said, what did we say about the families? Are they more like their family, the elements, or are they more like the representative member? Do you remember that? Are they more, our little Muppet Daddy, is he more like the monsters? Is he more like the other monsters, or is he more like the Muppet Daddy? Which one was he more like? The monsters, right. The monsters are furry all over. The monsters have googly eyes. The monsters have crazy mouths. They are more alike than they are like the Muppets. The families are more alike. Even though they do have representative members, you got the smallest one in both family. They're both pink. They're both little. They do have representative members, but this little monster girl is more like her family than she is like the little pink boy in the other family. Do you think that's true for real families too? You're more like your family? Sometimes. All right, so our book was called People in My Family. And the columns are more like each other than the periods or the rows that have similar members. Now, what do elements want? This is what we talked about last time when I talked about the children. Remember about how some of the elements want to gain electrons, some want to lose electrons, and it's because they all want to feel like what? Who do they want to feel like? I'm putting a crown on my head. What do they want to feel like? They want to feel like the king. Who are the king elements? You remember what they're called? They're all the way on one side. They're nobility. They're the noble gases. They all want to feel like a noble gas. A noble gas. Now, why? Why do they want to feel like a noble gas? What's special about that? And it has to do with, I drew a ball on y'all's. It's right here, up here. I drew this 8 ball. And I said that 8 is, what rhymes with 8? Great, that's right. 8 is great. So fill that in. So when you're studying for your test, remember 8 is great. They all want 8 electrons. So it's called the octet rule. The octet rule. And they each want 8 valence electrons. Now, I'll tell you a little story. The guy who discovered this said that there are patterns in nature. And just like in music, an octet, a musical scale has 8 notes. Some of you people who know about music, I don't know much about music, but some of y'all do. And a musical scale has 8 notes. So he discovered this, he said, it seems like atoms want to have 8 electrons in their outermost valence level. Well, everybody, the scientific community said that's stupid. There's no way that that's true. Music has nothing to do with chemistry. He died, and then they went, oh, he's right. So he never found out that he was right while he was alive. I'm hoping that once he was dead, he found out. Yeah, you were right. They were wrong for calling you stupid. All that they all want 8 valence electrons, just like how you said. Now, the next thing is our periodic trends. And this is where I was telling you about we can think of the elements like children or babies. And this is what I talked to you about when I read you the book, okay? The alkali metals. I'll pull my periodic table down. So here's our new standard. We're working on standard 2. And what we're learning about, I circled it in green, is we're learning about bonds. Chemicals getting together to make bonds. Okay, here's my periodic table over here. And the alkali metals are this first column, and the alkali earth metals next to them. Do you remember what I told you? They're the bad parents. Do they want to gain or lose their little electron children? Do they want to leave them at Walmart or steal somebody else's? They want to lose. So these alkali metals and alkali earth metals want to lose electrons. Over here, the noble gases, next to the noble gases, the halogens, in that first column there, do they want to gain or lose electrons? Do they want to? Are these the bad parents who leave their babies at Walmart, or are those the crazy people who try to steal a baby from the hospital? Which one are they? They're the crazy people. They want to gain electrons. So here we have our crazy nurse. She's dressed up like a nurse, and she's going to try to steal an electron. Now, when my youngest was born, he was born at the hospital at Cobb Wellstar. Anybody been there? I don't like it. But anyway, that's where he was born. That was okay. It's just when my mom was there. I didn't think they did a good job. But anyway, so he was born there, and when you have a baby, they put baby LoJack on them. They put these things on them that if someone comes in and tries to steal your baby, the doors will close, and you can't go on past the door and steal the baby, because this really does happen. People dress up like nurses and try to steal babies. So they tell you as a new mom about all the hospital security and about how your baby's safe. Nobody's going to come in and steal it. Well, 10 days after he was born, he got RSV. It's kind of like COVID. It's a respiratory virus, and he almost died. We went to Scottish Rite. Anybody ever had to go to Scottish Rite down in Atlanta? Yep. So it's a children's hospital, and so he's in the respiratory virus wing, and he's in his little crib, and he's only got a 50-50 chance of making it. They told him 50-50 he's going to live or die. He was a little fighter, so he lived. Well, I wanted to know what sort of security measures they had to keep my baby safe. Where was the baby LoJack? Where was the little thing to keep people from stealing him? And so I asked the nurse, does he have the thing where the doors will all shut if somebody tries to steal him? And I'll never forget her. She was a hefty-sized nurse, and she just laughed at me with her deep laugh, and she said, "Honey, nobody wants your baby. He's sick." And so I was like, "Oh, I want him." But they don't have baby LoJack of the babies at Scottish Rite because nobody wants them. She's like, "Your baby's sick. Nobody wants this baby. Your baby's not any good." Oh, hurt my feelings, calling my baby no good. But anyway, he lived. He was in the hospital 8 times that year. It was a long year. All right. Now, and remember I told you these metals here in the middle, what are they like? What kind of parents were they? What kind of parents were they? The ones in the middle here. What were those like? Do y'all remember that one? Peace and love, dude. Peace and love. What are they like? They're the hippies. They're the hippies. And what do they do with their little electrons? Are they trying to steal anybody's? No, that's way too uptight for a hippie. Are they trying to give them away? No, that'd be too unloving for a hippie. So what do they do with all their little electrons? They let them run around free and wild. They share them together and they let them run around. So now the non-metals over here, I sort of skipped that. These guys up here, they are your what kind of parents? These are the hippies. These are the bad parents. These are the crazy parents. But these right here, what kind of parents are these? And remember, some of y'all have these kind of parents. Divorced. So these divorced parents, the non-metals right there, they work out sharing arrangements. So the nonmetals work out sharing, just like some of your parents have sharing arrangements. You have to go to mom's, you have to go to dad's, they share you. All right? And sometimes that's kind of contentious, isn't it? But so those are our divorced parents. You can draw an arrow down to there. Now, metals are our hippies. I tried to jump ahead to them. And they let their electrons run wild and free. And it's why metals can conduct heat and electricity. It's why they're shiny. It's why they're ductile and malleable, why you can make them into wires. It's all because of these wild free electrons. Being shared hippie style. Do you remember what I said was the end of the hippie free love? Letting the children run wild and free. Do you remember? Who ended all that? Charles Manson, the Sharon Tate murders, the Helter Skelter murders. People decide maybe that wasn't so good. All right, so we're going to talk about two main kinds of bonds. So we've talked about elements, we've talked about things like gold and silver, and you did reports on them. But now we're going to talk about elements getting together like water. Water's not just hydrogen or oxygen, it's both. It's H2O, right? So how do they get together? How do they make these bonds? Well, we're going to talk about two primary kinds, ionic and covalent. In ionic bonds, electrons are transferred. They are transferred. I'll say transfers electrons. In covalent, they share electrons. So these are our divorced parents. They share electrons. Now, we're going to do a little bit of math with this because compounds have to be neutral. So when we do figure out the electrons, you have to do the math like, it is hard math, things like 1 minus 1 is 0. You have to, at the end, make it equal to 0. And this will make more sense once we do our activity with it. Now, what holds ionic bonds together? So with ionic bonds, you'll have one atom that loses electrons and it becomes positive. You have another atom that gains electrons and it becomes negative. So one's positive and one's negative. And what do opposites do? Do they attract or repel? Attract. There used to be a Paula Abdul song about that. But I never can remember it. Every time I try to remember it to sing it to people, I start doing instead, if you want to be my lover, then first you got to be my friend. It's very similar to it. And I can't get the right tune in my head. I once heard that Spice Girls song is the most sticky song. So no wonder it pushes out the Paula Abdul song. It's something about, I can't do it. It's something about opposites attract. It was a video with a wolf, cartoon wolf, and her dancing around, and the cartoon wolf is smoking. So that was very controversial. He was a cartoon smoking. So you're not supposed to watch things with smoking in it. Okay, so with ionic bonds, it's because opposites attract, and we have two kinds of ions, charged ones, and the first ones are called cations. And how you can remember their charge is because cats are wonderful, sweet, darling creatures, right? We all love sweet, darling, wonderful cats. So we can remember that cations are positive. Now, we might not all agree that cats are wonderful and positive. I know it might shock some of you, but some of you might not like cats. But I think we can all agree on the opposite. So the other one is anions, and how we're going to remember that they're negative is we can all agree, because we live in Georgia, that fire ants are horrible. If you had a choice between being bit by fire ants or seeing a nice positive cat, isn't the fire ants worse? Isn't it fire ants more negative than a cat? Now, my sister-in-law absolutely hates cats. She's terrified of them. And I'm like, how in the world? Okay, I understand being terrified of a vicious dog who can bite you and kill you. But why in the world are you terrified of cats? Well, it turns out that when she was a little girl, a cat clawed the eyes of her dog. They got infected and he died. So she hates cats. But you know, that's kind of unusual. Most cats don't kill people by clawing them. Darrell, are you with us? Are you getting your notes down? Fill in all the blanks. I give you a grade for this. So you get graded and you have to color them too. It's the easiest worksheet you'll do in here. You just write down what I write down and you get a grade for this. Don't y'all agree this is the easiest worksheet we do? Yeah? All right. So here are some examples. We're going to talk about this. Let me roll this up some. This always makes such good YouTube videos. Oh no, don't tell me it did that. Go back up, that'll fix it.
Put it back on there and then tap it. Go back where you have it a little bit more.
Let's see if I move this part of it. No! I should have taken these drawings off. Yeah, I think we're going to start over. That didn't get it. Let's mark it all the way out. All the way outward. Okay, that's not so bad. I can live with that. All right, so do I need to rewrite that in, Zach? Are we okay? Can I leave that empty? Do I need to write opposites attract, positive, negative? Are we good with that? I'm fine that if it's gone, if it'll just let me roll. All right, so here is an example. Let's look together at the periodic table. Look at lithium. Okay, so lithium is right here. It's in this family, and this whole family has one valence electron that it wants to lose. How we remember that is it's in the first column. And the first column, they all have one atom, one electron they want to lose. Well, if it loses an electron, and electrons are negative, what charge will it become? Positive. See, like I've got my little shirt on. Think like a proton. Be positive. Okay, so electrons are negative. If you lose one, the atom now has more protons than electrons, and it will become positive. So lithium, when it becomes an ion, you do it like this. You can either do +1 or just a plus. We like to, stop that. We like to leave off ones in science and math. So it's an understood one. Okay, magnesium is in the second column. So what charge do you think it's going to be? If lithium in the first column is +1, what do you think magnesium will be in the second column? Did somebody say it? +2. So write Mg, and then up at the top corner write +2. Okay, aluminum. Now we just ignore the hippies. And if we're counting from over here, aluminum is in the third column. Does that make sense to you? See how I've got that Roman numeral 3 right there? That's what it's about. So it's in the third column, so what's aluminum going to be? +3. Y'all are brilliant. So do Al +3. Okay, now, then for the other ones, over here you start on this side and you count how many columns it is away from a noble gas. So fluorine is 1 away from the noble gas. Can you see that? It's on the first column from the noble gases. It becomes, it's an F, and it becomes -1 because it wants to steal 1 electron and to feel like a noble gas. Electrons are negative, so it's a -1. Sulfur is 2 columns over. If you look right here, it's 2 away from the noble gas, 1, 2. So what's its charge going to be? -2. Y'all are doing awesome. -2. Nitrogen is 3 columns away from the noble gases, so what's its charge going to be? -3. So there's a pattern. Now, I left it off of mine. I drew you a little periodic table. I'll draw it real quick here. 1, 2, 3, 4, 5, 6. Okay, so here's our pattern. These are -1, -2, -3, and then you skip. Then it's, oh, I did it wrong, plus. I started thinking too much about my drawing. +1, +2, +3, skip, and then it goes back again, -3, -2, -1, zip. And the zip means 0. It does not try to gain or lose electrons. So that's the pattern. Write that down. Now, we will write that pattern on those periodic tables I gave you that will be your cheat sheets. And you can actually write that down and kind of cheat sheet it on the test. So did you put a little plus near your sweet little cat and a minus near that mean old fire ant? So remember, anions are fire ants negative, cations are positive, and opposites attract. They're getting all lovey-dovey. All right, how do we feel so far? Page 1, 1/4 of the notes. Good? Okay, let's go on. Oh, I left off this one. I drew it on mine, but not yours. So FeO3. Any guess what that is? In my little picture there, that's supposed to be a nail. I know I didn't draw it very good. And on the nail is rust. So our example, what you should write down is that's rust. Rust is an ionic compound called iron oxide, Fe2O3. So that's rust. Did I leave anything else off of your notes? No. All right, so look at the next picture. How do they form compounds? Okay. So there's a thing called Lewis structures that help with this. So what we're going to do now is we are going to do a little hands-on part to this. What you're going to do is, let me see how we're going to do that. Let me think if I want to keep rolling on the video. I guess I do. All right. So what we're going to do is I want you to stay sitting at your table. We're not going to move with our lab partners. And I'm going to give y'all a laminate little form here, an atom. Actually, I'm going to stop this. So now I'm going to explain it to you too, so for you guys at home. Okay, so what we have here are some laminated atoms. I want y'all to take one and pass it. 2, 3, 4, 5. 1, 2, 3, 4, 5. One per table. 1, 2, 3, 4, 5, 6. Yeah, we've got enough. All right. Take one of these and pass it. And then I want you to take a cup and pass it. 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 Take one per table and pass it. Dylan, take a cup and pass it. Okay, Miss Olivier, would you mind taking this around and letting them each dip out a half a cup of Cheerios? Now, are you required to eat your lab equipment? If you are allergic to oats, should you eat your lab equipment? No. But at the end, if you want to eat your Cheerios, you may. Okay? So they need, like that much per cup. So if you'll go take this around and let them have a little dip, but not like a,
Do you want them to scoop with their
They can scoop it, but yeah, with their cups, just like that.
Okay.
At least that much. All right, so for you at home, so you can feel like you're part of us, let me find what I did with it. Okay, everybody's got a laminated page with an element on it. And now they are getting half a cup of Cheerios. Honey Nut, because I like them. So if there's leftovers, they taste way better than regular Cheerios. Am I right? Honey Nut's better? Yes? I don't like regular Cheerios. I like Honey Nut Cheerios. If you're allergic to nuts, should you eat your lab equipment? No.
It's 1 cup per table, right?
Right. 1 cup per table. They're going to share this. We could pause it here. We're going to pause it while we're passing out. We'll come back.